This experiment aims to demonstrate indirect heating or cooling by transfer of heat from one fluid stream to another when separated by a solid wall. Through the experiment, students would understand energy balance across a concentric tube heat exchanger and the overall efficiency at different fluid flow rates under countercurrent and co-current flow conditions. This is the concentric tube heat exchanger used in the experiment. The transfer of heat from one medium to another is an essential process in almost all industrial and commercial processes. Heat exchangers may take many forms. The concentric tube heat exchanger consists of two coaxial tubes, one inside the other, carrying fluids of different temperatures. Due to the temperature difference, heat will flow from the hotter stream to the cooler one. This is the simplest form of heat exchanger. The water flow direction can be changed in our instrument, so that the flows are in the same direction, that is co-current operation, or in opposing directions, that is counter-current operation. In normal operation, hot water from the heating tank and pump passes through the hot-out braided hose and self-sealing coupling into the inner stainless tube. It then flows through the heat exchanger and leaves via the hot return braided hose. Cold water flows from the cold-out hose through the annulus between the clear plastic tube and the inner stainless tube. A useful measure of the heat exchanger performance is the temperature efficiency. The temperature change in each stream is compared with the maximum temperature difference between the two streams. It is assumed to have a perfect heat exchanger of infinite size with no external losses or gains. Before starting the experiment, familiarize yourself with the equipment. Identify the mains water supply, hot and cold water flow control valves, and the hot and cold water flow rate meters. Ensuring that you understand the flow directions of the hot and cold water streams. At stage 1, we are going to do counter-current operation. Check that the heat exchanger rig is set up for counter-current operation as illustrated in the figure. If the tube connection is not correct, you should disconnect the tubes at the plug positions and interchange the cold water out and return connections to the heat exchanger. Please note to fully close the cold water flow control valve before disconnecting the plug. In order to remove the tube from a socket, it is essential to push the loose gray ring into the socket, while at the same time pulling the tube out of the socket. Failure to do this will result in damage to the tube and/or the socket. Please note that there is no need to disconnect the hot water circuit and no need to turn off the hot water pump during this operation. Are the tube connections ready? Set the cold water flow rate to 20 grams per second. Then turn on the equipment set to run the circulating pump. Set the hot water flow rate to 20 grams per second. Then turn on the water heater. The hot water temperature controller is default at 60 degrees Celsius. Wait a few minutes until the hot water temperature reaches the default level. Check the stream temperatures and the hot and cold flow rates to ensure that these remain close to the original settings. When the system has stabilized with hot water temperature reached 60 degrees Celsius, record the water temperatures and water flow rates. Repeat the procedures with adjusting the water flow rates as below and record the water temperatures. At stage 2, we are going to do co-current operation. First, fully close the cold water flow control valve, disconnect the tubes at the plug positions, and interchange the cold water out and return connections to the heat exchanger. Push the loose gray ring into the socket to remove the tube from socket, while at the same time pulling the tube out of the socket. Interchange the cold water out and return connections. Push to plug the tubes. Are the tube connections ready? Again, set the cold water flow rate and hot water flow rate as shown below, and record the water temperatures. The experiment completed. Before switching off the equipment, please turn off the heater and fully close the cold water flow control valve. In the reporting section, calculate the power emitted from hot stream, power absorbed by cold stream and the temperature efficiencies under countercurrent and co-current operations. Also try to answer the questions. Thank you.